Good day. Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to discuss a couple of topics. The first one is the program application control and computer assisted audit techniques. And the second one is data extraction for computer assisted audit techniques. Program application control has three types of control. The first one is the input control. The second one is the process control. And the third one is the output control. Let's look at the input control first. There are several types of input control. The first one is the source document controls. Is basically where you have source document, and based on the data that is on the source document, you input the data or copy the data to the system. So it's kind of like manual process. And since it's a manual process, usually the control is done manually inside the source document. For example, a pre-numbered document. The second one is the data coding control. This is a bit different. A data coding control is where you put a digit to the coding of the input that you're going to input to the system. There are several types. We have the self-checking digits, for example. I'm going to show you how to do a self-checking digit here now. Okay, here now let's see. This is the uh, code of the document that you are going to input. Example. Now, as you can see that we have 1, 2, 3, 4, 5 uh, digits, right? And the number is 1, 2, 5, 6, 7. Now, what we can do is to self-checking digits by totaling this amount. Yeah. Uh, Totaling these three amount, and we'll get 21. Now, since the total number of digit is 21, we can use this as a self-checking digit. So we have 1, 2, 5, 6, 7, and 21, right? So whenever we input data, the computer will calculate directly 1 plus 2 plus 5 plus 6 plus 7, 21. Okay, so the data is valid because it passed the self-checking digit. Another way of doing self-checking digits is by rounding the number to the nearest exponential 10. So for example, we have 21. This means that 21 is 2 times 10, right? The nearest number is 2 times 10, which is 20. So what we can do is 20 minus 21, or we have 1 in here, like this. Yeah, so this is what we call the modulus self-checking digit. Of course, the real modulus self-checking digits is way more complex than that. You can see in the book, you can see in the chapter, one of the example using modulus 11 or 10, if I'm not mistaken. The third input control is what we call the batch control. Batch control is not only for input control, but it can also be used for the process control. So basically what we do here is try to batch some of the input first, and then make a control based on the batch input controls. There are several types of batch control. For example, we have the control totals and we have the hash totals. Now I'm going to demonstrate you a few of those examples. Now here, let's see that we have three inputs. Yeah, the first one is file number 125671. Second one is 134561, and the third one is 123455. So what we can do is that using control totals means that there are three files, right? There are three files that is going to be inputted inside the system. So what we do is for these three files, we input it in batches. So these three will be inputted directly together, right? So for these three pages, there's what we call the control totals, which basically is going to compute the total amount of the file. So a control total will put number 3 here because we have three files. That's what we call the control totals. Well, the second one is the hash total, is where we calculate the total amount of these numbers, yeah, of these three files directly. So we have 1 2 5, sorry, 1 2 5 6 7 7 1. We have the 1 3 4 5 5 6 1, and we have 1 1 2 3 4 5 5. Now in the hash total, the all of this number will be calculated like this. So this is the hash control for the batch input, these three file batch input, and this is the control total for these three file batch input. And the fourth one is the validation control. So validation control ensures that the data that you're going to input is valid. There are three types of interrogation for validation control. We have the field interrogation, we have the records interrogation, and we have the table or entity interrogation or file interrogation. Now let's look at the example of a few of the interrogation. Now let's look first on the field interrogation. An example is there. Okay, let's see. There's a transaction here and the quantity here. As you can see here, we have a control message. It's stated 1 until 10. So this means that I can input from 1 to 10. So I'll just input, okay, let's see, 8. Okay. So yes, doesn't the control is done. What about if I mistakenly put 11 here? Okay, so it gives me an error, right? It gives me an error. I have to try again. I'll just change it to 7. Okay, I'm done with it. Now, this is called the field interrogation. So it interrogates the field based on the control itself. The control is from 1 to 10, the numbers that can be inputted. So if I put other than 1 until 10, then it will show me an error. Now, the second interrogation is the record interrogation. So we have the 1, 2, right? So one of the record interrogation is after 1 and 2 is called the sequential record control. So this should be 3, right? So if I put 4 here, it will show me an error. Yeah. And the last one is the file interrogation or the table interrogation. An example is the label here. We have the sales trends or sales transaction. So it will actually show me the sales transaction file in here. So it makes sure that the label name is correct. Yeah? So that's called the file interrogation control. Yeah. Okay, and number 5 and number 6 is basically our validation controls. However, for number 5, they will show you a correction. Just like when you mistype and then on any Google application, right? And will show you the correct words from what you mistype or when you create a typo. Yeah. So it will automatically correct your mistake instead of showing you an error message. And the sixth one is still the same. It's actually validation control, but instead of only for one application, it can be given to all of applications inside the organization. So it's called the generalized data input system. So it has a standardized validation control for all forms of inputs inside all applications. Yeah. So that's the number 6. Okay, next is the process controls. So this basically will process the will control the processing of the data inside the information system. The first one is the run to run controls, which is basically the same with the batch input control. So you actually create a control total or hash total for each run of operation. So for example, we have process 1, process 2, process 3. For process 1, we have the control total or hash total. And process 2, we have the same control total or hash total, and so on. And it's usually done in batch processing. And the second one is the operator intervention control. As it stated, the one that creates the intervention is manually created by a controller. Usually it's done by an auditor or internal auditor to actually try to intervention manually, or even supervisors when they want to uh, run the system. It will be paused and then intervened by the supervisor. Supervisor needs to authorize the run of the system first. And the third one is the audit trail controls. Of course, you probably can guess this is where the transaction logs, audit logs, or any kind of logs are recorded. So whatever you do inside the system is being recorded and it's being controlled by using this audit trail control. And the last one is the output control. The output control should ensure these four things: not misplaced, not misdirected, not corrupted, and not violating the privacy policy. The output control itself has two types of output controls. The first one is what we call the batch system output control. So this is basically when you control the outputs in batches, kind of like manual and online pages. For example, when we want to print an output, usually it will be spooled first. Uh, for example, if you try to print several files, it will be uh, in waiting line, right, before you print out. It will be spooled and saved inside the printer memory. Yeah. But only some of the file that is actually being run inside the printer. Yeah, and this will be there. There's going to be some risks in exposed in here. Yeah, for example, if other people, if the file is still stored inside the printer memory, other people will, if the file is confidential, other people who has access to the printer, they can actually access the memory inside the printer and reprint the confidential file. And the second one is called the real-time systems output control. Well, basically, we have a couple types of control. The system performance control is where you have to make sure the real-time system output is actually produced frequently and on time and in real time. Yeah, so it performed well. And of course, we have the chain of custody control, in which it makes sure that all of the output that is produced by the system is actually administered or controlled by the appropriate department. For example, output one is controlled by department A, and then based on output one, we release output two that will be controlled by department B, and so on. So there's a chain of custody for the output. Who does this output belong to, and who can this output be read by, for example. Okay, next is how we can audit a system or testing the application control of a system. We can do it in a couple of ways. The first one is what we call the black box, or around the computer. And the second one is the white box, or basically through the computers. We have discussed this on the accounting information systems class, and I think I already gave you a couple of cases to practice with the black box or the white box. If you weren't in from my class, I'm going to give you during this session the cases. Okay, so and the third option is by using the computer aided audit tools and techniques, or CATTS, right? So this is basically similar to the white box and black box, but we're using a computer program in order to conduct the test. We have several tests. The first one is the test data method. This is prone to the black box one, the black box method. We can have a test deck, in which case we have the black box itself, kind of like simulating the information system. And then we put valid data, and we assume that by going through the test deck, the valid data will give us a valid output. Yeah. And we can also test with invalid data or incorrect data. And when we put it inside the test deck, this means that the output should also be an incorrect or invalid output. Other than that, we can also use the base case system evaluation. It's similar with the test deck, but instead of using only one simple test deck of an application system, we actually try to test it along with all of the other systems. For example, if we are using SDLC to develop the system, we are going to test all of the application control inside the SDLC along the process, along all of the phases inside the designing process. And the last one is where we actually try to trace the data, not only looking at the input and output, but we can also look at the results of the data inside the system. So this one is the white box one. So in here, we can see the logic and the application control for each of the processes inside the system. For example, one valid test data we input it inside the system, and the system will or the CATS will trace the data from one process to another process to make sure that the data actually has access to the appropriate program control. And the second one is what we call the integrated test facility. Integrated test facility is actually done and owned by the IT auditors. The ITF is also a white box approach, so it can test the logic and process control inside the application. So it's basically an automatic techniques which uses the ITF auditing modules, and by using the modules will set up a dummy entity inside the application, and by using the dummy entity, it will automatically create what we call the test data method previously, but by using a tracing method. Yeah, but it's done automatically. Yeah. And the third one is what we call the parallel simulation. So the generalized audit software is also a type of parallel simulation. So this means that you actually have a copy of the information system or a copy of the data that came from the information system. And at the same time, you can do a lot of simulations inside the copy of information system. So usually you actually try to simulate it by using the copy of the uh, information system. Other than that, if you're using the generalized audit software, you are trying to simulate the data that is being extracted by the generalized audit software. So it's pretty similar. It can simulate the operations. It can also simulate the data transaction. Now, following the generalized audit software for data analysis and transaction analysis, now we came to the second part of the session, which is the data structure and CATTS for data extraction and analysis. Now, let's look at data structure first. So, data structure is basically divided into two types, which is the data organization and the data access. Yeah. In the data organization, we have we call the flat structure, which is the sequential structure and random structure. While on the access, we have a couple, which is the index methods and the non-index method. The index method, we have the sequential access, we have the index sequential access method, and we have the random access method. While on the non-index method, we have the hashing pointers. Yeah, we use the hash algorithm from previously similar to hash totals, right? Okay, now let's look at each of these individually. We have the first, the sequential organization and access method. So this is like, if you still remember cassette tape or magnetic tape. When you want to read or write data into the or from the magnetic tape, you have to do it sequentially. So one by one. For example, we have the first one here, and then the second one, and then the third one. So it has to be read it in sequence. When you want to write the data inside the storage, it will also be written in sequence. And the second one is the index random file structure and random access. Yeah, so random organization and random access. And this one is the index one. In the index random file structure, as you can see here, all of this file, which is already being indexed by this key value, this is the data inside the file. The key value is here, and it will be saved inside the cylinder number, surface number, and record number of a hard drive, for example. So in this example, for this data is recorded here, this data is recorded here. So whenever the users want to access the data or read the data or even write the data inside the storage, it is done randomly. Yeah, it is done randomly. For example, compared to a cassette tape where you have to play it one by one in sequence, magnetic disk will be spin, right? It will be spin, and once it's being spin, then the access will be random. Yeah, the access will be random. Okay. Next is the hash structure. So the hash structure is basically using pointers. Yeah, will be discussed after this. Uh, by hashing algorithm. Yeah, for example, we have a key value here that is going to be searched inside the magnetic disk here, storage, data storage. By using hashing techniques, it will be converted here. This is one of the hashing techniques by dividing prime number with the key number here. And we got this, and based on this number, we can see the physical address, which is cylinder number here, surface number here, and record number here. And then we can find it inside the data storage. This example is called the physical pointers. Now, there are several pointers inside the hash structure. We have the physical access pointers, just as we discussed previously. So physical access means that which cylinder inside the hard disk, which record and which surface. Well, the second one is we call the relative address pointers. So instead of pinpointing the actual physical address, it only pinpoint a range of the address. So we have a range of the address, and then we look at it in sequence. Yeah. So we have 1 to 10, and then look number 1, number 2, number 3. Okay. So the data is at number 3. Yeah, you can read and get the data from it. And the last one is actually similar to an index uh, method, which is basically using a logical hashing algorithm. Yeah. But instead of showing it to physical address, it directly showed to record. So using hashing pointers is very fast, but it has several disadvantages also. For example, as you can see here, since it's written and read at random, so this means basically inside the hard drive there are actually several spaces that is being done or being utilized inefficiently. Inefficiently, yes, inefficiently and ineffectively. Yeah, that's why hard disk is usually fragmented. Yeah, fragmented because it's not actually in a very structured uh, physical storage. So this means that hard drive needs to be defragmented. Yeah. Once there are too many records that is being stored randomly, it will be fragmented. Okay, next we're going to look at the database structure. Usually we look at the data structure. Now we're looking at the database structure. There are basically three types of database structure. We have the hierarchical structure and network structure, where uh, there are parent file, and we have the child file or the master file and transaction files in hierarchical, just like a tree, or structured network. Yeah. Um, I will show you how it looked like. Okay, the one above is an example of hierarchical diagram. So a parent can have relations with only a child. So one parent, a couple of child, something like this. And the second one in the below here is called the network diagram. So a child can have two relations with two different parents here, and a child can have a relation with another child also. This is called the network diagram database structure. And the third one is called the relational structure. This is the most popular database structure. And we already discussed this on our accounting information system classes. So I'm not going to discuss this in more detail. But if you haven't come to my class, you can ask me directly in regards to the relational structure. But I'm going to show you a bit what a relational structure look like. Okay, this is the many-to-many relationship of hierarchical data structure. As you can see here, we have the parent here, and each parent can has relations with a child, just like this. Yeah. So child, parent, and a child, parent, and a child, parent, and a child, something like this. Yeah. And the next one is the relational database. A relational database is usually depicted in using the entity relationship diagram. If you're following my systems analysis design classes, then this means that you will be able to design a database on after mid sessions. But if you also taken my AIS classes, we already discussed about this entity relationship diagram. So basically, we have the entity, which is the employee there, or the table, yeah, and we have the attribute, which is the column inside employee, employee ID, employee name, and so on, right? So this is called the attributes. And we have the relationship, which is assigned. So employee is assigned to company car, right? So this is the relation between employee entity and the company car entity. In this example, we have a restriction. In this restriction, it shows that one employee is assigned to one company car. Yeah. So one employee here, one, is assigned to one company car. Yeah. A further restriction is also applied in this case. So only one employee can be assigned to one car or company car, or one employee is assigned to zero company car. So this means that not all employee is assigned to a company car, but a company car is only assigned to one employee. So employee is assigned to one or zero company car. The company car is assigned to only one employee. Yeah. It's also the same with manager and laptop. Manager is provided with only one laptop. The laptop is provided for only one manager. While for customer and sales order, customers places many or zero sales order. Sorry, customer places zero, one, or many sales order, while sales order is being placed by only one customer. Yeah. So each one of these sales order can be only made by one customer, and so on. So this is what we call the entity relationship association. Uh, if you still have questions regarding the entity relationships diagram and associations, please to ask during the synchronization. Okay, and the last one is that we're going to talk and that you are going to practice is the generalized audit software. So this is basically the most widely used CAATS. It will help the auditors to do a lot of things here, selecting, reporting detailed data until recalculating values in data. and it's very popular because it's very easy to use. The auditors doesn't need to have a lot of IT uh, skills. As long as the or she can use an application, then this means that it can use the GAS, right? So several types of GIS are available, the simple structure and the complex structure, as you can see in the chapter, some of the example. Now, what we're going to use is the audit command language, or ACL. I already provided the link to the application so you can download and install. However, as I mentioned previously in our earlier meetings, that it's a Windows-based application, so you need to have a Windows operating systems to install the ACL. Now, we're going to discuss ACL in practice and some tutorials inside it after the mid-exam. However, before that, please read the start guide. I already put the start guide file also on the log, and do tutorial 1, which I will given to you as an assignment. Yeah. Okay. I think that's it from me, right? I'll be seeing you guys after the mid-exam. Good luck with the mid-exam. Good day. Assalamualaikum warahmatullahi wabarakatuh.